All right, here we go. We are going to continue with this. Oops, I got to turn this on. We're going to continue with this section 3-4. Like I said earlier, they kind of took 3 different topics. They put it all in one lesson. That's why this one takes so long. Hopefully, they won't all take this long. All right. So we're going to talk about slopes. What are the first 2 things that we talked about in this lesson? What was the first one we talked about on section 3-4? The distance formula, right? And then the second one was the midpoint formula. And now we're going to figure out what the slope is. Well, basically, what does it mean when you talk about a slope? Okay. Let's just talk in like normal terms, not in math terms, though. But that's good. All right. So you know a little bit about slope already. You probably did that in Algebra 1, right? Rise over run is what he said. Yeah, and that's perfectly fine. It's a great answer. But just in normal, everyday terms, if I talk about the slope of this line, I'm finding how what? How steep it is. It's not really curving because it's a line. It's straight. Okay. So lines don't curve. All right, but they are steep, correct? Right? Some are flatter than others. They still have a little bit of steepness to it, whether they have no steepness at all or really, really steep like this, okay? They have a certain steepness to it. And that's basically what the slope is. We're just saying, how steep is this line, all right? Does it go like way up like this, or does it go really flat? Okay, so that's what we're talking about. And you can also talk about what direction it goes. Let's talk about that first before we do anything else. So, first of all, let's say, here's my fancy artistry. That's a car. All right, that's my car. And it's going up the hill, right? Now, from left to right. Okay, we read from left to right. This car from left to right, what's it doing? Is it going up the hill or down the hill? So up the hill. So we would call a slope that's going in this direction, all right? So a line that goes in this direction, it goes up the hill. So we're going to call it a positive or a negative slope? Call it a positive slope, okay? So this would be a positive slope, all right? If it goes from left to right, if it goes up, then that's positive, okay? Everybody with me on that? Because people would look at this and say, well, this thing goes up, but it goes up from what to what? From right, from right to left. Yeah. If I'm going from right to left, you say, oh yeah, that goes up, right? So if you're in a car and you're going this way, boom, all right, you're going this way, like, oh, I got to hit this hill, I'm going up the hill, right? But in the math world, we're looking at it from left to right. So from left to right, this slant, this line is going what? It's going down, okay, which would be what? Negative. Good. Everybody good with that? All right. Let me do a couple more, and then we'll talk about the rise over run, which is something that, again, you guys are familiar with, but we're going to talk about it again. So what if you had slope like this? Now, when I think of slopes, like in the real world, like activity-wise, what do you think of when you think of slopes? Okay, skiing. Skiing is what I would think, okay? I used to do a little bit of skiing. I was never like a great avid skier, but I was a pretty decent skier for the few times that I went skiing. And I first started, I remember I was at Camelback in the Poconos. That was my first time I ever went skiing. My friend Keith, he had gone one time before, gone a few weeks before that. He was all into it. We were at a youth camp for my church, and he's like, okay, we're going to go skiing. I'm like, okay, I've never been skiing before. He says, oh, I've been. He went one time, like he's this big pro or something, you know. So I'm like, okay, I'll go. That sounds fun. I always wanted to do that. So we went, and they took us to this part right here. It was completely flat. Sometimes they call it the bunny slope, right? Actually, this isn't even the bunny slope. This is like to get to the bunny slope. The bunny slope, it just wasn't really, really steep, you know. So if you started going down, you wouldn't hurt yourself. But at first, it's just flat, and you had to push yourself. So, okay, here's another great drawing. You can tell I'm a terrible artist. I've never claimed to be a good artist. Oh, there's their hands. There's their hands. Okay, and that's me. You can't tell? The haircut? All right, so there's he's actually more bald than I am. Well, I'm not bald. I cut mine on purpose. I got to cut mine every 2 weeks. So let me finish, please. Stop. It's not about you. It's about me, okay? I'm the teacher. I get paid tens of dollars to to teach. All right. So anyway, so here's my skis. So how fast would I be going if I'm not pushing off with my poles? Okay, I'm just standing there like this, and it's completely flat. How fast would I be going? I'd be going 0. Okay, 0 miles per hour. Okay, so we say the slope right here, because is this really steep at all? No, there's no steepness at all. So even if I put like a ball there and just set it there, would it roll one way or the other? Not if it's completely flat. Would you agree? It wouldn't roll at all unless I pushed it. But, if I just set it there, listen, if I just set it there, it's not going to move at all. So how fast would it move? 0. So what is the slope of a horizontal line? It's 0. It's 0. Okay, it's not nothing. I'm glad you said that, actually. Okay, because it's not nothing. 0 is something. Do you know that? Because you can add a 0 to something, can't you? You can multiply something by 0. You can even take 0 and divide it by something. Now, you can't do what, though, with 0? You can't divide a number by 0. Okay, did you know that? We'll talk about that another day, maybe. All right, so anyway, so you can do stuff with 0. All right, so 0 is something. It's on the number line, isn't it? Yeah, so 0 does exist. Would you agree? So this slope is 0. It's not nothing. It's something. It's 0. And that's kind of weird because we think, yeah, but Mr. Hamrick, 0 is nothing because that means that it doesn't exist. Well, no, it just means we have none of those particular things. Anyway, the slope is 0. So this would be a positive slope. This would be a negative slope. This is a 0 slope. Everybody got it? We got one more. What other kind of line? I got one going to the right, one going to, I'm sorry, if you're going left to right. Yeah, one going to the right. Yeah, from left to right. Yeah, and then one going down, one going up, one going down, and one not going up or down at all. Completely horizontal, that's 0. What are we missing?
Up and down.
Give me a better word. We have a slope that's horizontal. Thank you. Okay, the next one would be vertical. Okay, so that would be vertical. Now, what's the slope of that? Well, it's not positive, right? Because from left to right, it just goes straight up. It doesn't like slant at all, does it? It's not 0. Why is it not 0? Because what kind of a line has a 0 slope? A horizontal line, okay? It doesn't have a 0 slope. It's not positive. It's not negative. So what could it possibly be? Well, here's my story. Do you want to hear my story about me hanging upside down? I'll say it. What's that? Absolute? No. It's vertical. Yes, we've said that. Thanks for playing along, though. All right. So this is a vertical line. All right. So when I was in college, I went to Liberty University. Can you tell I went to Liberty?
Yeah.
Okay. So I went to Liberty, and I was in the ROTC. This thing was Reserved Officer Training Corps, I think, something like that. Anyway, it was like you could kind of, it's not exactly in the military, but you could kind of pretend you're in the military and you're in college. We actually, if I would have stayed longer, I might have got a uniform and stuff like that. And they do drills and they do all kinds of stuff. But I went out on a couple trips with them. The one time we went to VMI. You ever hear of VMI? Anybody know what that is? It's the Virginia, what do you think? Military Institute, VMI. All right. It's kind of like going to the Naval Academy or to West Point, but it's in Virginia. It's just people don't know about it quite as much as the other ones. But they have a football team, it's a college and everything else, right? But you're in the military. You have to be in the military to go there. I think it's Army. I'm not exactly sure. I think it is. So we did this thing called rappelling. You know what rappelling is? All right. So this is the ground, right? And this is the ground up here. All right. So I was up here. Ooh, that's me again. All right. And we have to go down to the bottom. This is a good ways up. It had to be 70, 80 feet up, maybe 100 feet. It was a long way up, okay? Well, a long way down, all right? And down the bottom were these big old boulders, big, huge boulders, all right? So there's boulders, and here I was. And we got hooked up with these ropes. It was actually just one single rope, and what do they call it, a Swiss seat, I think they called it, where you take the rope and they showed you how to tie it. You go in between your legs, around your waist, and all this, and it's nice and tight, right? And then what they do is you're hooked up. I mean, the end of the rope is hooked up, so if you actually fell, the rope would stop you from falling. So what you would do, the rope, you held it behind your back like this, and that would start and stop you. So if you pulled it out like this, it would give slack to the rope, and then you would just, gravity would take you, go down the hill, right? And then you put it like this right behind the small of your back, and it stops you, boom, and it stops, okay? So they wanted you to go, and I saw several people do it, and we actually had this was completely straight up and down, vertical. Earlier in the day, we had a slope like this, all right? And we went down it, no big deal. I could have walked down that one. It wasn't even that bad, right? This you can't walk down, right? So I get to the edge. I'm fine. I sent other people do it. I really wasn't that nervous or anything. But he said, and you're facing this way, right? So your back is this way, and your feet are here. So here's my feet. There's my feet. There's my body. There's me, and I'm holding on to a rope that's attached somewhere up here. Okay, so I'm like this, right? So he says, okay, you have to be perpendicular, right? There's geometry for you. You had to be perpendicular to the side of the mountain right there. Okay, I thought I was like that, right? I was like that at first, right? And then you just kind of go down. I swear, this is me right here. I was like that. He says, no, let up more, right? So I'm like, okay, I'm letting up more. And so guess what happens? My head's starting to be down here. Where are my feet?
Too high.
Yeah, well, my feet just came out from under me because he keeps telling me, let out a little bit more. And I thought, man, I know I'm perpendicular. I know math. I'm a math major in college, right? And then I let out a little bit more, and boom. My feet are completely up in the air. So here I am.
Do you have a helmet on?
I think so, but a helmet really wouldn't have done much if you fell on these rocks right here. Maybe if you bounced up against the wall, it might have helped you. But so here I was. I was here, right? There's my feet up like this. I'm holding on to the rope. This is me. I'm completely upside down. Well, there's a whole bunch of people over here, right? A lot of people are going down, so it wasn't a big deal. But the guy starts yelling at the top, the Army Ranger dude, right? He's like, don't move, whatever you do, don't move. I'm like, oh my gosh. And then I saw all these eyeballs coming up over the edge, looking at me like this. Here I am hanging upside down. I'm like, there's no way I'm going to have this guy rescue me, right? Nobody else has been rescued. I'm upside down. I was like, and so I started like bouncing a little bit. So my legs are up here, my head's here. I start bouncing a little bit. And then finally I was able to get my feet underneath of me. And man, when I got and then I was finally the way I was supposed to, like this. And then I went right down to the bottom. That's what you're supposed to do, like kick off, and then you hit the wall again, you kick off again, and come down like this. And the dude at the bottom, he was waiting for me. He's like, well, you had a rough start, but you got down here faster than anybody else did. And I was like, yeah, thanks. I said, there's no way I was going to get rescued up there. He says, yeah, I probably would have been the same way. And I told the dude at the bottom, I said, he kept on telling me to go. He says, yeah, I thought you were really tilted a lot. I couldn't understand. And then, so it was not my fault. I promise, it was not my fault. And but that was my experience with this kind of a slope. All right. All that to say, what if I would have fallen and gone down here? They wouldn't be able to identify me, would they? So I'd be unidentified, or I would be undefined in math terms. Okay. So I would be undefined. So what kind of slope do you think they call this then? Sometimes they call it undefined slope, all right, because there is no definition for it. And I'll show you, after we do the slope formula, I'll show you why it's undefined in a second. Remember we talked you couldn't divide by 0? We're going to talk about that too. All right, so this is undefined, or a lot of times we say that it's no slope. Has anybody actually gone snow skiing before? Who's actually been snow skiing? Not one person in here? Okay. No, like at a resort, like at a, not a resort, but a snow skiing place where you got the, you got the ride up and you rent the skis and all that. Nobody's done that? Okay. Or snowboarding. I mean, either way, skiing or snowboarding at a place. Well, anyway, they have these things called black diamonds. Shh. They have these things called black diamonds, and so, like the green one is like the easier ones, right? Then you go, I think it's that it's either blue or green. I forget what it is now. But I think green is the easiest. Then you go up to blue. It might be the other way around. And then after that, then you have diamonds. And they got black diamonds. So you got like a single black diamond, a double black diamond, a triple black diamond. The more black diamonds, guess what? It's not the easier. What is it? The harder it is. Okay. And the what? The steeper the hills are. Okay. And so even on a triple black diamond, all right, you'll never ever see a slope that goes completely straight down like this. Do you agree? Just listen to me. That'd be nice. So you'll never see a slope like this. It does not exist. I'm getting somewhere with all this stuff, okay? So that slope on a ski resort does not exist. You'll never see it. Now, you may see steep inclines like this where, it might be off the edge of the mountain kind of thing, but are there any signs saying, hey, go this way? No, they don't. They say stay away. They usually have fences up. It's in orange, danger, don't go down this way, all right? So these do not exist. So if you had a vertical slope, what would you say about that vertical slope? It does not what? It does not exist, okay? So several different ways you could say it. You could say it's undefined. You could say it has no slope, or you could say what? It just doesn't exist, all right? So it's not zero, because zero, what? Does exist, doesn't it? All right, we talked about that. So zero does exist, but a vertical slope does not exist. Now, that mountain exists, right? And going straight down, that exists. I would exist for a while until I hit the bottom of it, all right? Especially head first, all right? But the slope itself does not exist. All right, enough of that. I spent way too much time on that, but I like to tell my story. You guys don't seem all that impressed with it, though, but that's all right. Did you like my story? Yeah, so Timmy does a lot of rock climbing, right? But even that, Timmy probably could have never gone on that because it was like sheer, just flat rock. There was no crevices, I don't think, anyway. I mean, it was just completely flat. I mean, it would be really, really hard to climb up that, if not impossible. But anyway, so he's a little familiar with that kind of stuff. So let's do this. I'm going to draw this. Seen this before, right? All through this section. And let's say I put a point. Let's do a different color here. Let's go this pink. All right. So let's say I put a point right here and a point right there. And then I connect them. Now, on this one, I could go all the way through if I wanted to, because I'm not finding the distance. Oops. I'm not finding the distance. I'm not finding the midpoint. I'm just finding how steep it is. So does it have to start and stop at a certain point? No, it doesn't. All right, so this is a line, so it keeps on going forever and ever. When you found the distance, it had to be a line segment. Found the midpoint, it had to be the midpoint of a line segment. On the slope, though, the slope is actually a line. Or you could also find the slope of a line segment as well. So let's do this. You guys said rise and run, didn't you? Remember we did that, the point 1 and the point 2? Let's do that again. So what am I going to call this point right here? What's my ordered pair? If this is point 1, x1, y1. What are we going to call point 2 up here? x2, y2. Very good. Now, what'd you guys say to find how steep something is? You said it's the what over the what? The rise over the run. So watch what I'm going to do. This is very similar to what we did for midpoint, very similar to what we did for the distance. But we're finding something a little different here. All right? Tell me when you think I hit about right there. Okay. Well, I can fix it. Yeah, that's pretty good, actually. Yeah. I let go early. Tilted up. Boom. There we go. So let's say I started at this point. At the first point, I wanted to get to the second point. All right? If you look at, I probably should have put a grid mark on here, but if you look at the grid marks, there's no diagonal lines on the grid marks to graph paper. Agreed? Yeah. Let's go back to this. You've seen this before. See that grid mark? That grid? I'm not going to use that right now, but you can't go diagonal, right? You can only go up and down, left and right. So if I wanted to go from this point to this point, what I'm going to do is I'm going to go up, which is called my what? Starts with R, rise. Okay, so I go up to here, and then I go what? And then I run. In this case, I would run to the right. So if I rise and I go up, what do you think that's going to be, positive or negative? Positive. And if I run to the right, what's that going to be? It's also going to be positive. Agreed? Now, I could have also started at the second point and gone to the first point, couldn't I? Yeah. Let's do that in a different color. It would be. Exactly right. So watch. If I go, tell me when you think I hit. About right there? Okay. Oops, nope. I missed it pretty bad. Boom. There we go. Now it looks a little bit better. So I could start from the second one and go down to here. So this time I would rise, but how would I rise? I would rise what? Positive or negative? I would rise negative, wouldn't I? But then I would run what? That would run negative. So this rise would be negative. I'm not going to put 1. I'm just going to put a negative. And this run would be what? Negative. But what's negative over negative? Still positive. And this is a positive slope, right? From going left to right, it goes up, doesn't it? Everybody see that? So it's positive. See, this is positive rise over positive run. That's going to give us a positive slope. Now, let's figure out what this point is right here. What's that point going to be? Remember, you go over. How far did you go over to the left? This is our third time that we've done this now. How far over to the left did you go to get to here? X1, right, because here's X1 down here, isn't it? How far did you go to the left to get to this point? You went over what? You went over X1. So in order to go to here, how far did I go? X1. But then, how far did I go up? What's that little bit right there?
Y2.
Well, it's this little bit right here, isn't it? And how high did I go up to get to that? Y2. Everybody see that?
Yep.
All right. So now, you already know rise over run. That's easy. Both start with R, right? Nice and easy to remember. But let's now put it into a little formula, and then we're going to come up with a little formula. All right? So we'll have a formula for slope. We'll have a formula for midpoint. We'll have a formula for distance. And you have to keep all 3 of those straight. All right? And that's the hardest part, just knowing which one's which. So I'm going to write. By the way, we use a letter to represent slope. What do you think we ys? You'd think we use S, wouldn't you? Okay, it's M. It's the letter M. Did anybody tell you why it's M? Why M? Why do we use the letter M? Nobody knows, actually. All right, I've looked it up. They got ideas on it. I think there's like a Latin word, M, for modulus or something, which means it goes up and down. It's kind of like where we get mountain from, kind of. Not exactly, but kind of. That's the way I'll believe it, okay? So, I don't want to put, let's put an M right there. Put it in parentheses. Okay, so we use the letter M to represent slope. Everybody got it? For all I care, just think that it means mountainous, right? Slopes go up and down, so it may not mean that. It probably doesn't, but that's how I like to think of it. So let's figure out what the slope is. Again, I'll tell you what. I'm going to write that in here. Rise over run. Let's do the yellow one since they're both positive, okay? So how far is it? Distance, right? How far? The length of? How far is it from here to here? I'm going up and down, right? So am I using the X's or am I using the Y's? Using the Y's, right? Because Y's go up and down. Right? How do I find the distance between this Y point and this Y point? What do I do? Minus. That's the key. That's what I wanted to hear. It's minus. Timmy, up here. So I'm going to use minus. I'm going to subtract. That's how you find the distance between 2 points, isn't it? If I know this point right here and this point right here, I subtract, right? If they're going along the same direction, right? Vertical or horizontal, I just subtract them. So what am I going to subtract then? You could do that. You could go y1 minus y2. I'm going to write it like this because most books write it like this. I'm perfectly fine if you go y1 minus y2. But I'm going to go the top one minus the bottom one. Is that all right? So what would that be? y2 minus what? y1. Right? So whatever that point is, say that's at 2, and this point is at negative 4. What's the distance from 2 to negative 4? What is it? From 2 to negative 4?
No, 6.
It's 6, right. To get to here, that's 2 places right there, and then 4 more, right? Because what? It's 2 minus what? Negative 4. 2 minus negative 4 is 2 plus 4. 2 plus 4 is 6, okay? Everybody got that? That's why you subtract. What about the run? What are we using for the runs? We're using the x's or the y's this time? Use the x's. Notice, the y's go on top. Why do you know the y's go on top? Because it's rise and then overrun. Okay, the rise is the y direction. The run is the what? The x direction. Excuse me. All right, so what's that going to be? Let's go from this point to this point. Let's find the distance of this horizontal yellow segment right there. So from here, yeah, let's go x2 minus x1. Now, it's really important. I'm going to put an or. Somebody said y1 minus y2. That would be perfectly fine as long as you do what? Yeah, okay, that's good. That's good. But we're not going to really talk about absolute value. But if I go y2 minus y1 and then subtract, how am I going to subtract the x's though? If I switch the order of these, then I have to switch the order of these, okay? Because if I kept this x2 minus x1, it would change the sign of my fraction, okay? So I could call it x1 minus x2. It doesn't matter which way you do it as long as you do them in the same order. That's super important. You hear me on that? So you subtract the y's, you put it on top, subtract the x's in the same order, subtract them in the same order, and put them on the bottom. So if you go the second point minus the first point for the y's, you got to go the second point minus the first point for the x's. Okay? You got it? This is the way the book will probably write it, right there. But it doesn't matter as long as you subtract them both in the same order. Okay, and that's your formula right there. Let's write it.
What is it?
It's right there. It's in a circle. It's m equals y2 minus y1 over x2 minus x1. Let me show you one more thing about this before we do an example, okay? What's this, 50? We're out of here? Okay. So a lot of times they'll do this. This is weird. They'll actually probably do this before. Let's do this. Let's scooch this over. This is going to look weird, but I'll tell you what it means in a second, all right? For Algebra 1, you probably don't care, but when you get into upper level math, you might see this. So watch. I put a triangle there. So it kind of looks like what? Triangle Y, triangle X, right? But it's not a triangle. It's actually, I think if you shade that little part in, I'm not really sure. I'm not perfect on this. But it's kind of like a triangle. We just draw it as a triangle. This is a Greek letter of the alphabet, and it's called delta. All right? It's a Greek letter of the alphabet. You've seen these college kids, right, with like fraternity, sorority shirts and that kind of thing. You'll see some shirts with delta on it. There was actually a skit on Saturday Night Live. Does anybody even watch that anymore? Yeah, it used to be huge. I mean, on Monday, all the kids would talk about, oh, did you see this on SNL, right? Saturday Night Live. Now, hardly anybody knows it's even on. I don't ever watch it anymore. It's just not funny anymore. They got all political and stuff. I don't need that. So, but it used to be funny. And then they had this one skit about the sorority, and they're all like Valley Girl types. You know, they all talked, you know, like that. And so their sorority was called Delta, Delta, Delta. And when they would call on the phone, this is back before everybody had cell phones. You had like one phone in the house, right? So the girl would answer the phone and she'd say, Delta, 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 can I help you, help you, help you? And so people would say that. It was like a little catchphrase, you know, that people would say all the time. Shh. Talking. So anyway, that was kind of a catchphrase back in the day. So a lot of people back then knew what Delta was. So if you said Delta, most of the people back then in the 80s would have said, oh, Delta, 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 can I help you, help you, help you? So anyway, may not be funny to you, but talk to somebody my age, and if you say Delta, 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 maybe they might be able to repeat that for you. But it's a Greek letter of the alphabet. What it means is the change in something, the change, all right? The change in whatever. So this is the change in Y. And how do I find the change in something? Well, I just subtract, right? From one to the other. It's the difference between them. So that's what it means. So this isn't super, super important, but later on you might see Greek letters and they might, you know, you might need to know what it means, but that's what it means. It means the change in Y and the change in X. Sometimes I'll say that. I'll say, okay, what's the what's the formula for slope? And you might tell me, oh, it's the change in y over the change in x. That's perfect. I love that. All right. Or you could say rise over run, or you could say y2 minus y1 over x2 minus x1. But the change in y over the change in x is a lot easier to say. Everybody got that? All right. Probably something that you didn't really need to know as far as geometry, but I don't know. I just thought that was interesting. Okay. Let's do an example or a couple of, let's do two examples. So they actually give you an example where they give you a graph. And I'll tell you where the points are. So this is at 1, 2, 3, 4, -1. So they got a point right here. And this one is at 0, 2. Got a point right there. Now you connect them. And you want to find the slope of the line that connects those 2 points. Okay? So that goes there. That goes there. There you go. It's a line. Keeps on going. Oh, that's a weird arrow, but you get the idea. It's another weird arrow. I want to find the slope. I want to find out how steep it is. First of all, just looking at it, what kind of slope is it? It's a negative slope, so you know it's going to be negative, right? So what you're going to do, you're going to take 2 points that you know. You know this point right here. What is this point? It's 0, 2. It's not just 2. 0 on the x, 2 on the y. What's this point down here? 1, 2, 3, 4. What? 4, -1. Okay? Everybody with me? So you could just count if you wanted to, and that's perfectly fine. I'll show you a better way in the next example, but you could just count. So how far do you go to get from here to here? That's your rise, isn't it? Everybody see that? And then how far do you go from here to here? That's your what? Your run. So you could just count, since they gave you a graph. It's pretty small, right? You don't have to count a lot. So how far did you have to go to get to here to here? You went 1, 2, what? 3. So what's my, and you went down, didn't you? So what's my rise? It's -3. So my rise is -3. What's my run? So I'm here now, right? And then I go 1, 2, 3, 4. What's my run? It's +4. You went to the right. You started here and you went to the right. So it's positive. So what's the slope? M is the slope. The rise is -3. The run is +4. That's your slope right there. It's as easy as that.
But it's going to get harder.
A little bit. Not much. At least for this. One more. We got about 3 minutes. I can fit this in. Everybody got that?
Yeah.
Just counted the rise to the run. If you wanted to, you could have gone up and then to the what? To the left. How far up did you go? You went +3, but then you went left 4 places, which is negative. Still rise over run, 3 over -4. Is 3 over -4 the same thing as -3 over 4? Yes, exactly the same. You could write it like that, or what's one more way you could write it? Whoops. You could put the negative out in front. No, you cannot put a -3 on the top and a -4 on the bottom. What would that give you? That would give you a positive. Is this a positive slope? No. So you could put it right out in front. See these things that I've circled? They mean exactly the same thing. Okay? Everybody got that?
Yeah.
Okay. Let's do one more and we'll quit. This time, I'm not going to give you a graph. I'm going to give you the 2 points, and you have to find the slope between those 2 points. And I'm not going to graph it. 1, -4, and 3, 2.
So these are the points at which they're at?
They're the 2 points that they're at, right. So, I mean, if you really, really wanted to, I wouldn't do this, but you could plot the points, do the graph, count, and all that stuff, okay? I'm not going to do that, though. We have a better way. Why do we have a better way? Because we just came up with a formula, didn't we? What's the slope? Let's write it down. What's the formula for the slope? y2 minus y1, and then x2 minus x1. What does that mean? Well, this first point is our first point, right?
Yeah.
Kind of redundant. But anyway, this is our x what? 1, and this is our y1. This is our second point, so this is our x2 and our y2. Everybody got that? So if you need to label it, feel free to go ahead and do that. So let's do it. Let's subtract the y's. And again, it doesn't matter what order you subtract them in, as long as you subtract them in the same order, the y's and the x's. So you could go -4 minus 2, but let's do it like we have written here. Let's go y2 minus y1. So we're going to go what? 2 minus what? Negative 4. It's not 2 minus 4. It's 2 minus negative 4. Everybody got that? Okay, what if we subtract the x's? In the same order. I went from the second point minus the first point. So now I'm going to have to do what? 3, what? Minus 1. And now you just do a simple little math. What's 2 minus negative? It's 2 plus 4, which is 6, over what? Don't leave it like that. What would you always do with your fractions? Always simplify, so it's 3. So your slope of that line is 3. 3 over 1, or just 3. That's a lot easier, don't you agree, than getting graph paper out, plotting the graph, putting the points, drawing the line, counting up, counting over, right? This is way easier. And that's why we learn the formula, so you wouldn't have to go through all that mess, right? And that's how you find the slope. We good? All right. So your homework is section 3-4, we'll call it C, and it's 13 to 22. Page 133.
Timmy.
Yeah.
Timmy getting busy.
Did I what?
Timmy getting busy, bro.
Oh, did I not collect it?
I'm probably
Was it 3-4B? Yeah, if you have 3-4B, I'll take it tomorrow. I'll take B and C tomorrow, okay? Sorry about that.
I just want to know.
I'll take B and C tomorrow.